Hello, welcome to Module 8 of a course called Coding for Crosswords. For more information on the full course, please see the links below. Now in this module, we're going to read the library. If you remember the task we're trying to solve, it's to construct a crossword puzzle. And in the previous module, we learned how to read a description of the grid from a file. In this module, we're going to use that same idea to read a description of the library from a file. Now I've prepared a special library for you that's 12,000 words. It's the 12,000 most popular words in the English language according to Google. It's an older file, but that's fine. And there are many such word lists. This is just to be an example and show you how this works. In a more advanced module, we'll talk about the whole idea of word lists for crossword puzzles and how important those are. But for now, we're just going to read this 12,000 word list that I prepared for you. And there are a couple ways to get this list. Let's go to the browser, and the first way to get this list is that I've prepared a bit.ly link that goes to a paste bin. So if you were to type into your browser URL bit.ly/top_12,000, okay? Now that doesn't work in a Google search. Just cut and paste that up to your URL, and you should get to this page, which is just a paste bin. If you don't know a paste bin, it's just a very simple way to share files, and that's just what we're doing. And if you look, these are the top words. It's kind of a fun game. You can try to not look at this and then come up with the first 10 or 20 words in the English language on your own and see if you get them. It's going to be, the, and, in, for, is, that, by, all these type of words. But as you scroll down, the words get more interesting. And as you get down to 12,000, of course, they get quite interesting. The last one is, I believe, wizards, which is interesting. Just by coincidence, it's kind of a fun word. But yeah, that would be a good word for a crossword puzzle. So from this, there's a couple ways, even in this way, you can either cut and paste it, or you can hit this download button right here. That's pretty convenient. So click the download, and that will put it into your downloads folder. If you go back to the compile window here, I will see what we have in this directory. We have, remember our original file, a.c, and then we made up this file called test, which was our grid input. And now I'm going to move over from on a Linux machine, it goes here, top 12,000. I'm going to move it to here. So if you look at that file now, if we do what's called a word count on Linux, you can see it's 12,000 lines long. It has about 100,000 characters, so that's about 100,000 bytes. And if we look at it, it will be this same file that you just saw in the paste bin. That's all one way to get the file. Another way to get it is to cut and paste and put it into a notepad or another text editor. Even a third way to do it will be that I'll put links to this file to download straight from the course syllabus. So if you look at the links below and you go to the description of this entire course, you'll see some links to files that you'll need during the course, and this will be one of them. We'll use this same file for the whole basics half of the course to use as our main library. It's sort of a surprise, but it turns out that this 12,000 word library gives you some number of solutions for the dog cat grid. So it's kind of a right-sized library for us. It's not really enough words to make a crossword puzzle that you'd want to publish in a newspaper, but it's a fine library just to make crossword puzzles for your friends or your own use. So let's go to the source window now, and let's look at the file that we've been creating. 55 lines long now, so we're starting to add a lot of information to this file. If you're confused at this point and you haven't seen the previous modules, it's a good idea to go back. Otherwise, you may have a hard time following along with what we've built up so far in this course. Let's just review quickly what we have here. We have these include files, which just include resources that we're using in the rest of the file. Then we have this namespace std standard, which we're using by default. Then we've defined a grid struct. So this is a C++ object that we've defined. that has a number of functions. It has a name. It has a constructor here. And in fact, we can improve the syntax of this in a bit. It has some access functions that describe how big the grid is, how many rows and how many columns. It's a square, and it might not, or it's a rectangle. It might not be a perfect square in general. There's a way to load the grid from a file, which we've already proven works. And then we have a check routine that just checks to make sure that all the lines are the same size. And then we have a print. And then we've got some of the data that goes with the grid. There's the name, which is set in the constructor. And then there's this vector of strings called lines, which actually holds the characters of the grid itself. So it has the dog and cat that are already part of the initial grid that we're starting with. Then we have main. And we just create a grid, we load it, and we check it, and we print it. So let's use some of the same framework to create a library object. And we're going to start by just commenting this out again like we've done before, just to work on the library. We want a thing called a library, and we can call it lib or library. We're going to make it, and then what we're going to do is we're going to also read from a file. So let's call this routine read from file, and let's read from this file called top 12,000 text that we just read in. Or not, that we just downloaded, I mean, from the web. And you should have that file. You need that file on your machine so that you can issue this type of command. And then if it's, if you're in Windows, you're going to have something like C:, with these backslashes and stuff. But on my machine here, I just put that file right in the directory where I'm running the code. So I just do it like this. So let's make this happen. This is going to fail to compile because it doesn't know what a library is and it doesn't know what read from file is. So let's make those things. So let's go back up, and we're going to copy some of the same idea we did for grid, but this is a different object now. It's not a grid, it's a library. And we're going to introduce a new keyword called class. It's very similar to a struct. In fact, it's identical to a struct. It's just a different keyword, with the exception that by default, everything in a class is private. Things in a struct are public. The idea of private and public is convenient to let a class hide things. So if a class is trying to do something more complicated than just like the grid is just holding characters, that's pretty simple. But the library might be a little more complicated. It has to have some way of storing all these words in it. And it's convenient and it's sort of proper once you get to larger objects to make them classes instead of structs. Structs are usually reserved for just very simple data objects, which can be copied easily. And a class generally would take more thought if you're not going to copy it around a lot. So we're going to say class, and we're going to call it library, just because that's a good descriptive name for this collection of words. It's very much like, a library of books. We're going to use that analogy during this lecture. And what we need to do, though, because things in a library, like I said, things in a class are private by default, we need to initially say public to let some functions be private. We need some functions to be public because, for instance, the one we just want to do, which is void read from file, string file name. Where did I get this idea from? Well, it's the one that down here in the main, it's the one that I just made up. I want to be able to call that. I thought that'd be a good name for it. So I decided what the name was down here in the main, and then I said, okay, well, I better make it up here so that we're calling something. And what we're going to do is just steal this same code here from this code in the grid. Now, in general, when you're coding, you don't want to copy and paste code. In general, you'd like to reuse code by writing a function. But this is simple enough, and we're going to actually be handling the reading of the library words a little differently than reading of the grid. For instance, we may add like a point system where you can have the word in the library file with a point, like 50 points or 40 points, or 70 points if it's a really great word. So it's kind of okay in this case to go ahead and just duplicate some of this code, and it's not too big a deal. You do want to be aware of that in general, not to get carried away with copying big blocks of code and just changing like one thing in it. You'd rather make that code into a function where you parameterize that one thing, and then you can, in both cases when you need that code, you could call it, and then you can only just change that one thing that's changed. All the rest of the code is common. But in this case, we will just cut and paste it. So here it is. So we're going to have ifstream, remember that's the data structure that represents the input file. We open it, and we open it to this file name. So this file name comes from here. And then we read it while it's not end of file. We're going to read it into this line, and we're going to print out what the line is. That we don't really need right now. Let's put that out. And then we're also not going to support comments. Let's just take that out to be simple. The library file does not have comments in it. Let's just flip over quickly to look at what is the thing we're reading again. It's this file. It's just one word per line, and it's 12,000 lines long, right? So if we go back here to the source window, then we're going to read it, and what are we going to do with it? Well, we want a place to put that information, and just like the grid, right now we're going to actually keep it the same. We're going to change it in a little bit, but right now it's going to be another vector of strings, and we're going to call it words, let's say. So what we want to do is we want to say if the line is not empty, because we still have that problem of the last line in the file returning an empty line. If that's unfamiliar to you, go back to that previous module and just review that. It's a small glitch in reading input files. So if the line is not empty, then we're going to add to words, we're going to push back. So we're going to add one new word to our library. Okay, all right. So why don't we at least get that to compile, and we'll see if we're reading our library correctly. So let's pop down here and let's clear this and get back to our regular compile, which is -OA, and then a.c is the file we're compiling. It's all C++. Some people call those a.cpp or a.cc. I just call it a.c. And here we go. We're going to read, and it read, but it didn't print anything. So it probably worked, but we don't know. Let's put a comment in here then that says see out read, and then what? This is maybe a good mini challenge for you. How do you print the size? Pause for a second, see if you can figure out how to do that. But you're going to go words.size, or yeah, size. It's a vector, so it's a size. It's not a length. And that's it. We could say words. We could even say from file. This is kind of cute. We can put like a single quote and then file name, and then so you follow all this. So we read so many words from file, and we can do this thing where we kind of indent that again. So so here we go. So we're just printing the word read, and then the actual how many words we read, and then we're going to say we read like 12,000 words from file, and then we put this little single quote, and then it's going to put the file name in it, and then the closing single quote, and then the new line. So let's see how that runs, and it should at least now say read 12,000 words. So we think we have all the words in there. We haven't really looked at them yet, but we believe that we've got all the words read from that file into the library. So that's basically it. There's a couple of glitches, and one of them is that if you remember last lecture, I talked about the difference in file formats between Windows and Linux and Mac files. This file, if you download it from Pastebin, like I described with the download button, will generate a DOS or a Windows, that's the same, a DOS or Windows file format. If you're reading this from a Mac or a Linux, it's going to read an extra character. It's going to read this extra, what they call a carriage return. So let's investigate that. Let me just show you what that, to try to investigate what is it doing and why is it wrong. So let's print the first word first of all. So what do you think this word's going to be? Well, if we look at the file, there's a command on Linux called head. You can just print the first line. It's the, right? So let's compile this thing and let's run it, and it prints right here. You see it prints the. So that's because I added this line here that's printing the word. Now that's interesting, but there's something going on that you can't see, and that's because the carriage return is in there, but actually it doesn't print visibly. So it's a little tricky. So by the way, if you're on a Windows machine, you could skip the sort of next 5 minutes. This is just a detail of reading from either a Mac or a Linux, because a Mac is based on Berkeley Unix now, so since OS 10. So you've got a little bit of an extra hassle here only on those platforms. Or conversely, you could also, if you're on a Mac or a Linux, you could also just read on the website. I'll put up a Mac and Linux compatible end of line file, so you wouldn't even have to do this step either. But if you want to take it on and do it, it's not too hard. Here we go. So we're going to go back here, and I'm going to show you another thing. I'm going to show you the word 0 is the word the, right? Let's look at the length of that word. Let's print the length of that word. Okay. Let's go back and compile that and run it. And now look, it says the length is 4. Now, why is it 4? It's the. It should be 3. It's because this carriage return. And let's do something here. Let's do it in a loop. So let's say let's do 4 char. So we haven't. This is an interesting new concept. The strings are actually made up of individual characters. You know, when we put a character in single quotes, that's actually the fundamental data type called char. And so we can do C in words 0, right? So what's this going to do? This is going to iterate over all of the individual characters in the first word in our whole library, right? So the first word in the whole library. So this thing is the word the. And then this thing iterates over the T, the H, and the E. And then it's going to iterate over this weird carriage return, which I'm talking about right now. So let's go ahead and do that. Let's print that C, and you'll see what I mean. Okay, go back here and let's run that. And we run it, and here it goes. So you see the 4, that's this length that we're printing, and then it prints THE, and you still can't see it. So let's do this. Let's just make an int x, and let's assign it to C. Now when int prints, it's going to just print the actual ASCII value. And if you want a review of ASCII, we also talked about that in the previous module. So now instead of printing C, or maybe as well as printing C, let's print X. Okay, so now we're going to get the character printed, and then we're going to get the actual ASCII code, you know, the number, you know, like 68 or whatever. So here we go. Let's run that one. Now it's interesting. You see, okay, so 4 is still just the length of the word. We're still printing that. And then you see T is a 116. It's a lowercase t. Lowercase h is 104. Lowercase e is 101. That's all fine. And then here, there's nothing printed, but here's this 13. If you remember that decimal code 10 and decimal code 13 are the 2 end-of-line characters in ASCII. And the Windows files have this extra 13. 13 is the same as the \r. In the C language is how you sort of indicate the ASCII character 13, because it's a return. It stands for return, like carriage return. Whereas /n is the value for 10, which is the new line. So what do we do with this thing? Well, here's what we can do. It's not super hard to handle this. You just need to check one thing, and I'll make this a challenge for you. To try to write the code that will fix this. And this is more of a tough challenge, so I'll give you a hint too. So if you don't want a hint, stop now. The task, the challenge is to try to trim the \r off of that line. So we want to add the words to our library that don't include the \r. So we only want to add 3, not 4. So why don't you, that's a challenge. Try to add the code to do that, and I'll give you a hint now. So the hint is that you don't want to always just trim by one character, because then if you read a regular file on a Linux machine, you'll lose one of the characters. You want to check to see if that last character is a \r, and we do that like this. Let's just back out some of this stuff. Well, we can actually do it here. We're going to say, it has to be in here, right? So if the line's not empty, before we push the word, before we push the new word onto this list of words we've got, we're going to first get the length of it. So we know how to do that because we can say line.length, right? So now in this case, that's going to be the thing that's going to be 4 that we really thought was going to be 3. Then we're going to check with an if statement. If the line at this position, which is the last position in the line, remember, because we start from 0, if if the length is 4, because you got a T, an H, and an E, and then this carriage return, those are numbered 0, 1, 2, 3. So the last character, the fourth character, is actually in position 3 because it's 0, 1, 2, 3. Remember all this counting by 0 in programming. So to access the last character of the line, you always say the length of the line minus 1. And that's what this thing is. And we're going to compare that to this \r. Okay. So that is going to be the thing that fires if a word comes in the DOS or Windows format, which is what all the words in this file will come in. So for this file that we're reading, every single word will trip this clause and we'll go inside here to do something. And the something that we're going to do is we're going to trim the line by 1. And if you go to the string STL page, you'll see the routines for this. But it's called substring. Okay, this takes a string and it takes just a piece of it. And the substring that we want is going to be the substring starting at 0 because we don't want to trim anything off the front. And we're going to take length minus 1 of that string. Okay, so that's a way that you take a string and you shrink it by 1 on the end is what we just wrote right there. And what that does, you can assign line. This is like an assignment. It's like you take the original line, you shrink it by 1, and the substring call returns the new string, and then you assign it to line. Okay. So if you want the homework on that one, go to the STL page and look up the substring definition and how it handles the return value. Some routines will modify variables in place, and some routines will return the new thing. In this case, the substring returns the new shortened string, and then we push that. So now let's do that same thing, and we'll leave the same code here for the first word to see now if it does something different. So let's go back to the execute window, and I'll leave that code up so you can see how it differs. And here we go with it, and you can see now it still prints the is the first word in the library, but it's only length 3, and here's the T, the H, and the E, and we've got that pesky carriage return out of there. Okay, so if you were on a Windows box and you skip the last 5 minutes, this is where you'd want to join back in again. So that's all just a bunch of nonsense to deal with the file format stuff. But once you do that, it's a solved problem. You don't have to worry about it anymore in the rest of your code. Okay, so now I have a challenge for you, and this is for everybody. No matter if you're on a Windows or Mac or browser, we're back to everybody doing stuff together now. I'd like you to write the guts of this routine. We have a read, right? Let's add another routine, and let's call it, let's have it return a string, and let's call it get word. And I'm going to give you a hint here. I'm going to say int I. I'm going to let the caller of this function pass in which word in the library that they want to get back, right? Okay, so it's a string called get word, and this is, again, notice it's a const function, so we just put const in there because we're kind of thinking about how const works. If that's new to you, go back to the previous lecture and review that because that's pretty important. And what I want you to do is fill in all this, okay? Figure out how you're going to, first of all, you should do some error checking, make sure that the thing they're requesting is in range, and then return it, right? And then let's also add the code in main to call it. So let's for instance, call, let's try to find, the word, the 867th word, let's say, just for random choice. So go ahead and do that challenge right now, and we'll come back and see how you did. Okay, welcome back. Let's see what happened there, and let's walk through together how to do that. So first of all, we should have some kind of assert. Typically, these sorts of queries start with an assert. That's a good design pattern. They're asking the library for something. The first thing is, hey, is what you're asking for even reasonable? So one thing to check is that I is greater than or equal to 0, right? That's a pretty basic check. You can leave that as an assert on its own and put another assert for the uppercase, or you can kind of put them together. It's usually common to put them together. So you're going to assert that I is greater than or equal to 0. So you don't want to request a negative index. That'd be crazy. And you want to also assert that I is less than the number of words we have, right? So that's going to be word size. So does that make sense to you? So because we're always counting in zero again, remember, let's say we had 12,000 words in the library. Could you ask for I equals 12,000? No, because there is no word 12,000. There's a word 0 all the way up to a word 11,999. That's the 12,000th word, right? So when you check the bounds of I, it can be between 0, and it's okay for it to be 0, and it has to be less than the total size of the words. So from 0 to 11999, in this case, when we read this file in, that's the limit. And that's what this assert checks, right? So then what do we do? Well, words I is really where it is. That's what it is. And if you look down here, we added all those words into the words vector, right? So here's the words vector. It's a vector of string. So we literally just return words I, but we can't just put it there. We have to return it, right? It's a string. We want get word to return, give us the string. So how do we use this thing? Let's go down to the bottom of the file, back to the main. We've loaded the library. Let's print lib dot. Remember, this is a function that's not a global function. It's part of the library, and the library is called lib. The variable right here is called lib. So everything we do in the library has to be lib dot something. The dot gets the scope to the library, and since the library is a class now and has mostly private stuff, it only exports some public things like these routines: read from file, get word. From main now, because the words is private, we actually can't find, it won't let us see the words from here, and that's a good thing. That helps isolate the library's internals from the things that it's exporting to the public. Okay, so in here we don't say int I anymore. That's from the function definition. This is the calling of the function. We actually have to put the number in here, like what did I say, 876, and then we have to replace this const. Doesn't belong where you're calling the function. That's only from the function definition. So we also want to terminate this with a line feed. Okay, let's give that a try. We're trying to just read, this particular word from the library. It compiles and then it runs, and that word happens to be thanks. The word thanks. Okay, so what next? We've loaded the library up now with a bunch of these words. I think it's interesting to go ahead and illustrate the example of a stats routine. When you load these data objects as they get more complicated, sometimes it's useful to learn more about them and have the class itself produce statistics about its own data. So I'm going to run through an example of that right now. Let's go back to the source window and I'll show you what I'm talking about. Let's drive it from the caller first. Let's get rid of this sample word. What I'm thinking of is going to look something like this. I want something where I can say, hey, library, I just loaded you with a bunch of words. How about you compute stats? And then how about you print stats? You can do those as one function also, but it's kind of fun to have them separate just so we can see it more clearly. And compute stats will be modifying the library, and print stats will be const. So that's another difference in those two functions. It might be useful to separate them. So let's go back up to, this is the grid, remember. Now this is going to be the library. Now you start to see that the file is getting to be 95 lines, right? So you'll start to get, by the end of this basic section in this course, we're going to have probably 1,000 lines, I'm guessing. So navigating this file or even breaking it up to multiple files is fine too. Will become kind of a challenge. You have to get good at that. So I typically like just search for things. I'll just do in Vim. I'll just search. If I want to find the grid class, I'll look for a grid and I'll zip. Oh, it's a struct, struct grid. So I'll zip down to grid like this, or I'll do this. I'll go to the bottom of the file really fast sometimes, or I'll go to the top of the file, or I'll just jump the brackets down. So that's the library. That's the grid. So you'll see me kind of hop around. You'll have to develop your own techniques and style for how you get around a file like that. But I think searching for keywords is pretty key. You can search and then jump to where that is, because if you start to get to hundreds and thousand lines, you don't want to just be scrolling looking for something. That's just too slow. So I hope that you can follow along as I'm kind of jumping in here. Let's put this up top then, just because they're kind of new routines and they will make them easy to find at the top here. Now, what is compute stats going to return? It's going to be a void function, right? We're not going to do anything. And it's going to be some sort of empty thing in here. And then we're going to have print stats is going to also be void, and it's also going to be const, right? So those are sort of the templates that we want to fill out, right? And the stats I'm thinking of is word lengths. Let's just count how many 3-letter words we have, how many 4-letter words we have, how many 5-letter words we have. That's a good sort of stats stats challenge to take on. So we'll do it like this. We'll go to the private section down here, and we'll add a new vector. It's going to be a count. It's like a histogram of the word lengths. So it's going to be a vector of int this time. It's going to be counting how many words have that length. So hang with me here a little bit and we'll see. So let's call it count, okay? And what we'll do when we compute the stats is first we're going to make sure that compute stats has not been run before. And what we're going to do there is we're going to say assert count is empty. It's kind of a little trick that just kind of helps sanity check. Sometimes you have these type routine like compute stats. Oh wait, I have an error here. This shouldn't say lib, it should be compute stats. So sometimes you have these kind of routines that that prepare an object for further duty later. And it's nice to have some way of indicating that that work's been done or has not been done. And in this case, we know that the compute stats is going to fill in this count vector with some entries, counting the number of words of each length. So when we start the compute stats, we can just say, hey, let's make sure we haven't done this already. Because number one, we don't want to duplicate the work just for CPU use when things get more complicated. And number two, it might actually create an error. There might be something that compute stats does because it's a non-const function. It's actually modifying things in the library. It might be modifying the library in a way that if you called it twice, it might actually produce a different result than if you called it once. So making sure that you're calling things the right number of times is really important. So that's all part of the idea of designing a good class. You want to have a class that has good interfaces, they're easy to understand, they have reliable behavior, and the code itself checks to make sure that the user is not calling them in a wrong way or in an unsupported way. So that's an example of that, this first assert, that the count starts empty. And then we're going to do something now, which is a little new in this course. We're going to use this function called resize on the vector. And that's worth a look over at the browser window, right? So let's go back to the browser and let's do the search for the STL vector. I'm trying to get to the vector, and I like the C++.com site the best, although it doesn't really matter. What we want to do is under vector, we want to look at this element called resize. Just scroll down here, and if you look for resize, change the size of the vector. Remember before, this was in module 5, we had the first vector of strings that we played with. And we always took an empty vector at the start and we pushed back. So we added cars. Every time we push back, it adds a new car onto that train. In this case, we're not going to be adding cars one by one because we're going to be reading words that have different word length. We're going to want to first just resize the train, if you will. This count vector is like a train. We want to resize it up to some value. And I know from this data set that 18 is a pretty good number. You know, that's meaning we're going to be counting all the words that have the number of letters up to 18. So this is sort of preparing that. And because the classes like string and vector, and later we'll have more complicated classes, they generally initialize themselves well. When you resize something like this, all the ints get set to 0. If it's just a raw int, just a naked int, it does not get initialized. So remember that this is very important because they'll get you in trouble if you don't initialize the base classes. So anything that's an int, char, float, double, those things all need to be initialized by you. But if you're doing something with a vector or with a string, those all have their own constructors that do their own initialization. So here we are where we've resized it. Now what we want to do is we want to loop through the words in the library. And what are those? It's going to be string, let's call it S words, right? Remember this loop from before. We're taking words again is this vector itself. It's down here. I'll just flip down and show you. That's this thing, right? Words is the vector of of the actual words, of the strings. And then count is a vector of ints, which is going to count. So there's 12,000 words, right? This is a vector of size 12,000. And there's going to be 18 of these counts because it's one count for each word length. Like if the word is 4 letters long, there'll be one count of how many 4-letter words there are. This will become more clear in a second. So we're resizing the count array. So there's 18 zeros. All those buckets are 0. Then we're going to look at each word. And what are we going to do? We're going to take count. And we're going to, well, let's do this way. Let's make it temporary. Let's say length equals s.length. Okay. So len, this variable len, is the character length of each word. And this is a coding style thing again. I tend to write more verbose. I tend to like to have, like, if I'm going to put like the length of something in another expression, some people would put that right in there. So that's one way to do it. Another way to do it would just have been to say count s.length, right in there. Those are both fine. And there's times when you want to have the code more concise like this. I tend to kind of like more spread out code, and the compiler always optimizes this anyway. So writing a really tight, packed code does not give you faster code in general. It doesn't really matter. The compiler sees all of these things it can do, and it makes the code very optimal. So I like the kind of self-documenting nature of having like an intermediate variable. That's what these things are called len. Then it kind of clues you in, especially as things get more complicated, and you might get, pretty large expression in here. It's nice to kind of break it down into pieces. At least that's what I've always found helpful to myself when I go back and look at old code. So here we go. We're going to go count len, and we're going to just add one to it. Remember that plus plus? But there's something scary about this code, and the challenge is going to be for you to find it. So that's a challenge right now. Take a look at that code and see where this code would go wrong. This is going to cause a seg fault or a core dumper on your platform. It might be, blue screen or something. Actually, it shouldn't be a blue screen. That's like the OS has a problem, but it could be an app failure. So go think about that for a second, and we'll come back in a sec. We're back. The answer is pretty simple. It's that, again, it's when you're accessing this count, we've kind of hard coded this 18, which is also a little bit bad. We'll probably fix that later. Raw constants like this are not really good in the code. But this length here might be more than 18, right? There might be a word that's 20 characters long. That's a pretty long word, constitutional or something even longer than that. And what we should really do in here is protect against that. So if the length is what? Less than 18, then you can do this, right? Now again, you don't want to have less than equal because there is no index 18. There's only indexes 0 through 17. So 17 is the 18th element. So you always got to be careful about these off by 1 bugs in programming, where you might get an error code if you had that with an equal sign there. Right. So this is really kind of close to all we need. I'm going to have another challenge here to have you write the print stats routine. I think you know enough now. You've seen how we compute the stats. Now how we're going to print that out. So I want you to write the code that's in here. So write a bunch of code in this spot, right, that will walk over that count vector and print it out. So we can see how many words of each character length there are in the library. So go ahead and give that a try right now. Okay, welcome back. Let's see how you did. The print stats routine is what we're after in here. So let's take out this junk and let's put in what you want. Now, maybe you want something that says, a little header first is kind of nice, like here are the counts of each word length. Okay, just something like that. Now we want to loop over each of those counts, right? We've been collecting the counts. So if there was a 5-letter word that came through, we added 1 to the 5-letter bucket. If the 6-letter word came through, we added 1 to the 6-letter bucket. So we'd expect these counts to have something like maybe there's out of 12,000 words, maybe there's 1,000 words that are 5 characters. Maybe there's 1,000 words that are 6 characters. So that's what we're trying to print out, right? So we want to iterate over the counts, and we do that by doing this. We say it's not a string anymore. Remember, we were doing this for string vectors. Now we're saying for each count in the counts vector, let's print it out. And there we go. So that's pretty much it. So I think we might be done. Let's see if this will compile. Here's the print stats. The call is pretty simple. We just compute it, and then we print it. And here's the compute and the print. So let's go down to the window and see if we indeed got this right. Let's compile it. Oh, and it, okay, so let's go back and fix that error. So I used the wrong plural. And this is actually a good point. I usually use a plural for vectors. It's a style thing. You can decide what you want to do in your code. But if you have a vector of something, see, I called this the count. Now, a count is probably one count, like a count of something. You know, how many red things are there? That's a count. This is actually a vector of ints, so I think it really actually should be a counts, plural, right? It's a bunch of counts. It's a count of a 3-letter word and it's a count of a 4-letter word. So I think it'd be consistent, and that's why I did it up above when I iterated. I'm used to writing iterators where I'll have like a plural form of the word, but other people disagree, and so this is something that you can do as you wish. But let's go back and look then. If we change that to count, there's going to be some of these that we have to fix. So because I was calling it count up here. So let's go back to call it the plural, and that should be all we have to fix. Okay, let's go back and see if that compiles, and that does. And let's run that, and here we go. So here's the counts. So here are the counts of each word length. So 0, 26, 459, 818. All right. Here's a challenge for you. There's something glitchy about that. Not glitchy, but it's just not optimal. That we'd like to print out what the counts are. Like, okay, it says 1780. 1780 what? Well, we can count it. Like this is actually the count of 0-length words, by the way. So that's something we can also fix. We know there's no words that are 0 length. This is the 1 length. This is the 2, 3, 4, 5, 6, 7. So the 1760 is 7-letter words. We'd like to print that out. So here's the challenge for you, is go back to the print routine up here and modify this loop so that you're printing out also the word count that the count is counting. Okay, give that a try and see if that's something you can do. So here was the task at hand, was to try to change this. Now, so remember there are 2 ways to do iterations with for loops. This is the the easiest way, but the other way is the counting for loop, where we go int I equals 0, and then we have 3 parts, right? There's the initial condition, there's the termination condition, and there's the increment. And that's going to look like this. So we're going to have I start at 0. We're going to have I be less than the count size, and then we're going to go I plus plus every time. So it's going to bump I up. Okay. So now, though, we don't have a C anymore because that other form gave us the C automatically. We have to actually dig this out of the array again. So we have to say we're going to take I from 0 to 17, right, because it's 18 elements wide, and we're going to dig out element I every time. But now the whole point of this was that we were going to put in like maybe square brackets kind of just to look nice. Something like this. All right, you follow that? So it's going to just print a nice square bracket. That's going to print, the length, and then it's going to print the the closing square bracket, and then the actual count. There's one more thing too we can do, which is get rid of that 0 count. We know we don't want it to be 0 really. We don't care about 0-length words. So let's change this to 1. There's no reason we have to start at 0. Okay, so let's go run that, and it looks like this. So we read 12,000 words from the library. Here are the counts of each word length. It's kind of neat, right? It's a nice little, if you were to plot that, it'd be a nice little curve. There are 26 1-letter words. So what do you imagine those are? That's every letter, right? And then there's 459 26-letter words, which is getting close to. Actually, that's interesting. So what is 26 times 26? Oh, 600. So right, so it's covering 2/3 or 3/4 of the total number of 2-letter words. And then there are 800, 1200, 1600, all the way up to a max of, I guess this is the max. So 6-letter words are the most common in this library. So not that this is that amazing a data result. It's just showing you the idea of how you can load a library full of data and then ask it a question like the word lengths. So we're going to wrap this lecture here, and we're going to start to ask more deeper questions about the library in the next module. And the biggest question to ask the library is, do you have this word? And what words do you have that might be like this word? So we're going to be exploring how to do that efficiently in the next module, which is about hash functions. And that's going to be a really important module to make sure you understand. So I hope to see you there.